maths is at the forefront of everyone's conversation. It's on the front pages of the headlines every day almost. And for people who are asking, when am I ever going to need to do this, when they're sitting in the back of the maths classroom, when am I ever going to need to know about exponential growth? Well, it couldn't be any larger than it is at the moment. And it's been a strange time to be a mathematician, and in particular a mathematical biologist, seeing our subject catapulted onto the front pages of the headlines. But you're absolutely right about statistics and people potentially abusing them. I think people see statistics and numbers potentially as nuggets of hard, irrefutable truth, and they're tempted, when someone backs up an argument with a figure, to not question that argument. It's this idea of an illusion of certainty that people have when they see numbers. But actually, really, statistics can be used and abused, and often it's not that they're not the truth, but they're maybe just shining a light on the truth from one particular angle to paint a particular picture. And actually, we really need to illuminate the whole of the story to be able to understand what's really happening. The SAR model is probably the most basic model that we have for understanding the way that disease spreads. So it's called a compartmental model because we break the population down into 3 different compartments: S, I, and R. So S stands for susceptible individuals. So these are people who haven't had the disease yet. I stands for infected or infectious individuals, so people who have the disease and can pass it on to other people. And R stands for recovered. So sort of a euphemism for people who have either recovered or people who've died, unfortunately. We often call it the removed category because it's people that can't pass the disease on anymore. And there's an R number associated with each model, which tells you how fast that model predicts the disease will spread through the population.